Hi everyone. Today we are going to start on chapter 7.4 and the title is Confidence Intervals for a Proportion. Our objective for today is going to be to use the four-step process to construct and interpret a confidence interval for a population proportion. So we have what's called the four-step process for putting a confidence interval together, and we've actually done everything that we're going to do today, but we've done it in bits and pieces. So today we put it all together, and you have to know what these four steps are and how to write it all out when you put this interval together. So we start off with what's called the state portion, which is we state the parameter we want to estimate, and we also give the confidence level. Then we plan. We identify the appropriate inference method and we check conditions. Then we actually do, and if the conditions above are met, we perform our calculations. This is where the math comes in. Then we conclude. We interpret our interval, not the level. We interpret the interval in the context of the problem. And a confidence interval for a population proportion is often referred to as a one sample z interval for p. So where it says, what is the inference method? This is the inference method we're going to use. All right, now if I saw you in class today, I would have given you a four-step process template. That says state in the upper left corner, plan here in the right, do in the bottom left, and conclude on the bottom right. So if you'd like to follow this template, you can fold your paper into four large rectangles, and you can fill it out in this format. Okay? If not, you can just follow along with us as we go through the slideshow. All right, so here's our first example. A recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. So before we go through the four-step process, we're going to just highlight some key information here. So we've got a random sample of n equals 738 cell phone users. And the 170 is what you would call our number of successes. I know it sounds funny to think of walking into something or someone as a success, but the way the problem is defined, that's what we are going to consider our success, so we can get a p-hat. And we've got our confidence level at 95% here. So these are all important things that we're going to need to construct our interval. All right. So let's start off with the state portion. So we want to estimate P equals a true proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone at a 95% confidence level. All right, we want to just estimate using this random sample of 738 people or 738 cell phone users, what is that true proportion of people that would admit to walking into something or someone? So now we plan. So we're going to use what's called the one sample z interval for p. And we see that the word randomly is written, so we know that we have a random sample of 738 cell phone users. So you have to write that out in a complete sentence. Our large counts condition, the number of successes, 170, and the number of quote-unquote failures, which is 568, are both at least 10. Now, sometimes you're allowed to do this, but sometimes you have to actually calculate this mathematically, where we want to make sure n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. Okay, so now if we take, let's do this up here, we take our n of 738 and multiply it by our p hat of 170 over 738. Notice how 738 will cancel out. So 170 is definitely greater than or equal to 10. And that's what the first sentence or first part of that sentence for the large counts condition is stating. And you do the same thing for this second condition. where you would write 738 times 568 over 738. And you'll notice that you will also get 568. Now I'm out of room here, so I didn't write it out. But if the data is given as a count, you can definitely write it out in a sentence and not have to do it in that format. All right, here comes the do portion. So p hat is 170 over 738, and that's roughly 0.23. And that is going to be our point estimate on our confidence interval. So remember, it's your point estimate in the front. Now here we have our z star, which I'll remind you again, we're going to have to either use inverse normal on our calculator, inverse norm, and we would go 0.95 center area. Okay, that'll give us 1.96. Or you can go on Staplin and use the same procedure that we talked about last lesson. So that's 1.96. And here we have our standard error, which consists of p hat 1 minus p hat divided by n. All right, so if all that's done correctly, you have your p hat of 0.230 plus or minus, so here's your 0.230, plus or minus, again, this is all called the margin of error of 0.030. And when we add that to our point estimate and also subtract, we get our interval right down here of about 20% to 26%, 0.200 to 0.260. There is no standard for rounding here. I would say to be safe, 3 or 4 digits is more than fine when stating your confidence interval, but don't do any fewer digits than that. 3 or 4 is a good rule of thumb of digits to use. All right, last part of the 4-step process is the conclude part. So in conclusion, we are 95% confident that the interval from 0.200 to 0.260 captures the true proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. So this is what we call SPDC. State, plan, do, conclude. All right, that is our 4-step process. And on your homework tonight, that's what I definitely want to see, that you're following that SPDC format. All right, go ahead and pause the video and read through the example here. And I want you guys to try this problem on your own and check back when you're done, and we'll go through the whole solution. All right, so a recent study asked a random sample of 527 college-age students, so we've got our sample size, about their plans for purchasing a new computer. Now notice, a number of successes were not given. You were given p hat in decimal form. So p hat is 0.21. 21% of the respondents said they plan to purchase a Mac computer within the next year. Construct and interpret a 90% confidence interval for the proportion of all college-age adults who plan to purchase a Mac computer within the next year. All right, so here's the entire 4-step process. I am going to just highlight certain things. I'm not going to read through all of it because I want to show you that we can also do the do step on the calculator, and I want to save some time for that. But notice here on the large counts, you had to use p hat because you weren't given a total success count. And you do get a decimal, but you're going to round it up to the nearest whole number, which is 111. I believe it comes out to about 110.67 when you multiply that. And that rounds up to 111. And here you have n times 1 minus p hat, which again, you need to round that to a whole number. And the nearest whole number for that value, when multiplying by 0.79, you would round down to 416. All right, so large counts, we've got to do a little bit of math there. Now here's our do step, here's our p hat, which was given right away. Here's our z star value, and this would be using a 90% center area, gives us 1.64 or 1.65, and you will end up getting your standard error, and when everything's done correctly, you should end up with about 0.181 to 0.239. If your answer is slightly different due to rounding differences, it's not a big deal. Okay, if you're off by 10th or 100th of a percent, it's not going to be that big of a deal. Okay, so we are 90% confident that the interval from 0.181 to 0.239 captures the true proportion of all college-aged adults who plan to purchase a Mac computer within the next year. So all of this is your context, and you interpret your interval and not your level. All right, I wanted to finish up by saying you can do all of this on your calculator. Now, you can check on your calculator, I should say, okay? Because I am going to ask you to do certain things like give me the critical value, and that's portions that you can't do on your calculator. So if you go to Stat and Tests on your calculator, you're going to scroll down to what's called the 1 proportion z interval. You have to scroll down a little bit to the letter A. And for the first example, remember we had 170 successes, a sample size of 738, and a C level, you've got to write that in decimal form, of 0.95. Then you tap Calculate, and you should see this interval. And as you can see, it's not too different from what we calculated. I think we ended up with 0.200 and 260, I believe was the final interval. And yeah, that might be off by percentage-wise like 1/10 of a percent, so not a big deal. All right, now for the second problem, you can check with your calculator. Notice you can't put in 21%. You don't want to put in 0.21 or 0.21%. That is not going to work. What you have to do is multiply 0.21 times a sample size of 527. And you've got to round that up to 111. Just like when you're checking the condition, n times p hat. That comes out to be 111. And if you type all that in correctly, you will get your confidence interval, which again is not too different from what we just found out. And you get your interval. Now, it doesn't give you the critical value, so you still need to know how to do that. But this is a good way to check your work. All right, one last thing. So if you don't have your TI with you, you can also go on Staplet. And on Staplet, what you're going to have to do is you're going to have to scroll down to what's called the 1 sample z interval, and it's right over here. 1 sample z interval for a proportion, not the test. So you click on that and you'll see this screen. I already filled this out, and I wrote the variable name walked into something while talking on the cell phone. And I want to set this as my counts and categories. I have 170 successes, and I have 568 failures. Remember, that adds up to our sample size of which I believe was 738. So you need to do a little bit of subtraction of your successes minus your failures, or your successes minus your sample size to get your failures. Then you begin the analysis and ignore the bar chart and come down here to perform inference and make sure this is set to 1 sample z interval. This is your success category at 95% confidence, and you tap perform inference. This will give you your answer in percentage form, 20% to 26.1%. But it's pretty much the same thing as your TI. So if you don't have a calculator with you, you can get around it by using this. This is a little more complicated, but it will work. All right, so if you have any questions, please send me a message on Schoology, Google Classroom, or email, and have a great day, everyone.